All right, guys. So in the theme of getting started with Python, we feel that there's kind of 3 steps to do that, and that is one. Step one is to learn the basics of Python. Once you learn the basics, then you move on to step two, which is understanding the Revit API. After understanding the Revit API, you don't have to memorize it. You don't have to know every little bit about it. Just understand it and how to access it. And then from there, you just start coding. We're going to go into those a little bit more detail in today's webinar. Step one, learning basic Python. So I'm going to tell you about what is Python and why you should use it. And then we're going to move forward on over to learning about the pros and cons of Python, the good, the bad, and the ugly of Python, and what you can learn from that. After that, we'll talk about the types of Python. Types is probably a bad word. I will more say the flavors of Python and how to use that, and I'll talk about that at that time. And then from there, giving you some resources where you can get started and start learning about it. So what is Python? Python is an interpreted programming language. Give you a little background. Interpreted programming language is a computer is kind of dumb. It does stuff really, really fast, but it's dumb. It only can understand zeros and ones. All right. So when someone is coding and they're typing, that code or that typing that they're doing needs to be translated into zeros and ones so they can use it. So there's 2 types of ways to translate that to zeros and ones. One is to compile. That means that you put your zeros and ones in the machine and it spits out your exe or already put together as zeros and ones for you. Then you have interpreted. So when you type in a line of code like move the chair, it will automatically translate that to zeros and ones and execute the code for you at the same time. This one, by that stance and the steps that it takes, you can see that the interpreted takes a little bit longer, but it's still a very effective way to use it. All right, Python was built by Guido von Ronson in the 1980s. And the fun fact about Python is that the name didn't come from the Python snake. It came from Mighty Python. The creator really liked that show, and he named it after that. All right, so why would you want to learn Python if you haven't or you want to get convinced? I would say you could automate tasks and create your own things. And then from there, John Pearson, if you look up his YouTube channel, he has already demonstrated that if he does the same task using Python nodes versus using Python versus using out of the box nodes from Dynamo, that the Python does run quicker. So that's one way if you're having a project with a whole lot of elements that you need to run through, using Python will help speed that up for you. And the last thing is that Python will allow you to access the API and do things kind of what you can't do straight out of the box with, let's say, Dynamo, or what you can do with your normal Revit interface. Pros and cons. The biggest pro I think for Python is that it's a readable syntax. To print or to read something on the screen, you just type print, and you can read it. It reminds me of language, like I'm reading a paragraph in this code, so it makes it a very good first language for someone, and it's very popular today because of it. It's object-oriented programming. That just means that it's a way of programming in which utilizes classes and objects, and I like to think of that in Revit terms as in types and instances. So like a type is kind of a blueprint, and an instance which you have directly in your program. And that's kind of and it's very powerful. So you understand why Revit is the way it is, and the things about it, like the categories and types and things like that, just by understanding the code that's behind it. And that's because of object-oriented programming. Last thing, and I would say in pros, and there's probably many more out there, I just kind of have this list, is that it's diverse. So even if you decided that you don't want to use Python for Revit, it still has very diverse uses in this world, and it can translate really well to other things. So it's used in webs, it's used in servers, it's used in data mining, it's used in a variety of different uses, and it also works for both Linux, Windows, and Mac. So it's a very versatile language. I would say the cons for Python would be a slower speed. And we talked about that a little bit, being that it's interpreted. So slower speed, and it's open source. And open source to me is a negative and a positive. Open source does, you may have some issues in which people are changing the code or building it that can destroy your program. And that's where open source really comes into play. That's a con. Now we're going to talk about the flavors of Python. The flavors of Python, there's kind of two flavors. That's IronPython and the C Python 3. Now, when we talk about these IronPython and C Python 3, if you're wondering what exactly that is, well, these are interpretations of the Python language that is integrated with the .NET. .NET is just an open source development platform for Microsoft, which means that you can utilize, and .NET is used for building multiple things like UIs, programs, and things like that. So by using IronPython, CPython, you're able to kind of access this .NET library and utilize it in your workflows. These are the two that's used within Revit. IronPython, the key thing out of this, you don't need to know all the nitty-gritty, just know that Dynamo and Pi Revit uses IronPython and CPython. The difference between those, they use different versions of Python. So IronPython uses 2.7, CPython uses Python 3. As of this morning, these are the current ones. So the very top, where you see current version, that's the current version of Python, which is 3.10.5. IronPython is a 2.7, and CPython is 3.10.5. And when you're learning it, you just have to understand that there's some differences. And I find that in that little graphic on the right tells you the two main differences. And not the two main differences, there's other differences besides these, but these are the ones that caused me headache when I was learning Python and started switching over to Dynamo or Pi Revit and learning this to happen. So the first one is the print command. So in Python 3 and print command, you must have a parentheses, and then you put your string in to kind of display it. Python 2, you don't need that. So it will work with Python 2. It'll still work with the parentheses there, but the other way around doesn't. So that's one that you got to keep notice of. The next one, what I found was a big one, was the integers. In Python 2, when you have an integer or a whole number, and you divide it by another integer or whole number, you will always get another integer. So in that sense here, you're seeing that it says 1 divided by 2, and you get 0. That's because 0 is an integer or a whole number, not 0.5. But in Python 3, if you divide two integers, you can still get a float, which is a decimal, which has a decimal place there. When we look back in the next line, then we can see that if you put 1.0, that is now a float or a decimal, divided by 2.0, your answer will be in a float or decimal, which is 0.5. The same thing is true for Python 3. So that's something you need to take note of. There's other ones out there, but I find that these are the main ones that kind of caused me trouble when I was. Last thing is resources. I would say the websites that I went to, the main website I went to for Python is the python.org that has all this documentation, as well as the download executors so you can install it on your computer. And then also the website that I like to use as a reference is w3schools.com. It's a very good website, I think, that actually has you able to execute code within the web page, kind of let you try things. And I always use it today as a resource just to try out things and or just look up some commands that I haven't used in a while. But my learning really started with Python was with a book. So the day after I decided that I wanted to learn Python to utilize some stuff in Dynamo, I went and brought this book called The Learning Python in One Day. I think it's a very good book. You literally can learn Python in one day, and I had some fun with it. The other book that I read as well after I read that book was the Python Bible. My takeaway: you can use any book that you feel comfortable with is good, but my advice is that you can stick to beginner books. You don't really need the more advanced. Every advanced book that I've personally read, I look through. They talk about classes very heavily and how to manipulate them. And you don't really need that when you're dealing with Python for Revit. You just need to understand the class and know how to use classes. And that's all you need. And a lot of books, depending on the book, will either in the beginning section just tell you class and show you how to use it. Some don't. And you may need that first chapter in that intermediate book to move on and move forward. After that, we have some online courses, which is YouTube, Udemy, and Linda. These are all things that I've used. They have some good classes, some good information there. It's really up to whatever you feel comfortable with. Now that you've, now step one is kind of over. You learn, you got kind of used to the Python, and you read your book. Now, Carlo is going to take us off with understanding the Revit API.
Thank you, Donnell, for the introduction on getting going with Python. As you said, I'm going to go over the Revit API, and I'm going to continue this from my desktop. Just give me one moment. In a moment, you should see, yep, there we go. All right. So I'm going to start covering the basics of the Revit API and kind of how to use that with Dynamo and Python to write your own scripts. All right, so the Revit API, or Application Programming Interface, is essentially a collection of code libraries. These are in what's called assemblies. These are your DLL files. And what they allow is a developer to create the library of code that they want other people to be able to interact with in their own application. In this case today, we'll be utilizing them in Dynamo. What they do is they open up the access to those classes, methods, properties, and through those, your application can interact with another application. So in this case, we're going to be using Dynamo to interact with Revit using the Python code. And the Revit API, it exposes many of the things that you can do in Revit natively through the API, but do know it's not exhaustive. Autodesk is ongoing in their pursuit of expanding the API, opening up more capabilities. But there are some things that you'll find that you cannot do directly through the API. For example, purge unuse, commonly requested one that's not available, but they are working on improving it with each release. And sometimes they'll do what's called depreciation of some of their classes or methods, so things will change over time. You just got to kind of keep track of the changes they're making with it. The next thing I want to talk about is the Software Development Kit, or SDK. The SDK is a collection of files to help get you going with utilizing the API. You can download this from the Autodesk Developer Network. There they have each of the versions of Revit currently supported. They also have the point version sometimes there. And what's within the zip file that you get when you download that is what I have shown over here. You get some samples and your documentation. The documentation is primarily as a Revit API.chn file, which I have open here in the background. Those examples you get, they provide you with sample code and also the compiled add-in so you can test them out. And for example, if I go to this auto tag rooms, you see they provide you with a project. They provide you with the C# code and the compiled add-in so you can get going testing it. Now, as I said, these are generally in C#, Visual Basic, and C++. Those are the languages that are supported by the documentation. But as I'll explain later, using a common language runtime, we can use anything that's been developed for the .NET platform using other languages, so in this case, Python. And Donnell will give you an example of this, but I'll go ahead and cover it now. For example, if you're wanting to utilize this delete method from the Revit project you have open, you'll see that in the documentation they have syntax for C#. C# is very structured, so you have to specify your types generally, which is being done right here. But in Python, all you need to do is just apply your document and say .delete and then supply your element ID. But looking at the documentation, you'll see that it's going to return a list of element IDs. This is how you can relate back like C# to Python. So don't worry if they don't have Python documentation or examples. It's very easy to go between the two. All right, and in the next part, I'm going to cover the most commonly used, what's called namespaces, the Revit API. The namespaces are essentially a collection of classes that are organized. So instead of like throwing everything into one big grouping, they have a more structured organization to navigating them, so it's easier to get through the different classes and methods. The most common one you'll be using is the Autodesk Rivet.db. This contains the core functionality for Revit's database. So as you probably already know, Revit is essentially a database with a graphical user interface on top of it. So every time you click on a wall, yeah, it's 3D, but it actually has a database object behind it. And that's what the Revit API works with. And then the Autodesk Revit.ui, which is here at the bottom of this list of the documentation. Those are all the classes that interact with the user interface, and things like object selection. You would use the UI namespace. The Autodesk.Revit, and this should be .db, .discipline. Those are the more discipline-specific parts of the API for interacting with Revit database objects. So for example, if you're looking for changing stairs or working with your stair objects, you'd go under the Revit.db .architecture namespace for ducts, mechanical, pipes, plumbing. So pretty straightforward. All right, now we're going to actually get into the coding side of things. So I'm going to start off with Python and how it interacts with Dynamo. So in Dynamo, you have two main ways to take and utilize Python. The first one is the Python script, which I have frozen down here. Basically allows you to write your Python directly in here with a basic editor. And while this is pretty easy to use, you know, straight out of the box, just start typing, I really don't prefer to use this method. What I prefer to use is loading in my script as a string. So what I do is I point to my file path. And in this case, my replace lines.py script. It could also be a txt. We're just reading text. And then pushing it into my Python script, and then supplying my inputs with that. One thing to note is whenever you're dealing with Python scripts, you can have multiple inputs. All you have to do is, you know, set a input object to the capital IN, and then in brackets put the number of the input. They're all zero-based in an array, so 0 to n number of inputs. But you can only have one output. If you need multiple objects output, you can just send them out in a list and then retrieve them later by index. One of the most important things to cover whenever using Python with your Dynamo scripts is that you need to use the common language runtime. So you'll see here in the script that I'm working with in Visual Studio, I'm importing my common language runtime, the CLR. And then after that, I'm adding my references to those assembly files or DLLs. Now, you don't have to call them by file path. So you don't have to say like C and then navigate to your program files or anything like that if they're already being loaded by Dynamo. In this case, Dynamo is already loading its own assembly files. So Revit nodes comes from Dynamo, Revit services comes from Dynamo, and Revit services allows me to then interact with the Revit API. Because we're also running Revit, Revit API is already loaded, and Revit API.ui are already loaded into memory. And then once those assembly files are loaded, you can then start navigating through the namespaces and start pulling in the classes that you need. So for example, with the Revit API, I'll go to Autodesk.Revit.db, and I know that I'm going to be using my element category filter class, built-in category, and so forth. From the UI, I want to make a little pop-up at the end of my script, so I'm using the task dialog. All right. And next, I'll be showing how the Dynamo API interacts with the Revit API. So again, up here, I imported some stuff here from Dynamo. The most important one of the two that I got here is the add reference to the Revit services. Pretty much every time you write a Python script to run through Dynamo, you're going to be using this Revit services. And it has two main namespaces that you'll be pulling classes from. One is persistence, and the other one is transactions. From persistence, you'll be getting the document manager, and then from transactions, the transaction manager. Now, the reason why these are really important is they act as like a an entry point to using the Revit API, they create what's called a wrapper so that so that Dynamo itself can perform these operations with the Revit API. So using the document manager, we got a few very critical things here that you'll be utilizing it for. So from document manager in its instance that's running, this right here is your Dynamo side of things. And then after that is your Revit API side of things. So from the current DB document method property, you can get the document. And when I say document, that is your Revit project. The Revit API refers to projects as documents. Now you'll notice that I have doc and UI doc. The big difference between those is a document can be any Revit project that you have loaded in memory. So it could be in the background and not even be able to select anything in it. UI doc, however, is the active project that you have selected and running in Revit at that time. And it requires the Revit API.UI assembly that I got up here because it's interacting with the user interface. I also have here UI app and app. Now app is actually Revit, the application running in the background. And in that case, we're talking about like all the data and stuff being manipulated back there. The UI app, however, is the application that you, as the end user, are interacting with. So you'll find in different parts of the Revit API, it'll reference the app. Other parts will reference UI app application. Same thing with doc versus active UI doc. And whenever I write Python scripts for Revit, I just go ahead and define these starting off the bat because more likely I'm going to utilize them. The other part of the Revit services is the transaction manager. So anytime you make a change to the Revit database, you have to do what's called a transaction. The Dynamo API makes it easy to interact with the transactions of the Revit API through the transaction manager. If you call the transaction manager instance and say enter in transaction, supply your Revit project as a document, then as a document object, then it will go ahead and make sure that the transaction is started and ready to go to make changes to the database. Whenever you're done, you call the transaction manager instance transaction task done to finish it off. Something I wanted to take a call out here, just a little helpful tip for working with the Revit API is whenever you're looking at the documentation, you'll notice that, for example, the document class has a dozen or so export methods. And Python isn't smart enough to take and know which one you're trying to call because it's not structured quite like C# is whenever it compiles. Whenever C# compiles, then it knows which method you're trying to access. So in that case, if you are trying to access this here export method, you'd say export.overloads.functions. And generally, these are in the order in which you want to call them by. So they are zero-based in an array. So if I wanted to call the third export method, I would say functions and in brackets 2, and then supply my parameters as what is required by that method. All right. And then the transaction manager versus native transactions. As I said, the Dynamo API has the transaction manager to try to make it easier to do those transactions with a database. All you have to do is call that ensure in transaction and transaction task done to finish it off. But the Revit API has its own transaction class, and Donnell will talk about this too, where you can create your own transaction instance. You just say, transaction equals, or like T equals transaction, and then parentheses, put your Revit project document in there and supply it. And then you'd say like t.start to start your transaction. Whenever you want to commit those changes to the database, you just call the commit method. But if you happen to have an exception, you'd want to call like a rollback, so that undoes the changes that you try to do to the database. There's also a transaction group. Transaction groups allow you to put multiple transactions into one undo redo operation through what's called a simulating. So every time you do a transaction, that creates an undo redo operation. And if you're doing like 30 some transactions, you don't want 30 undo redo operations. So in this case, you'd want to do a transaction group. And then you also have the ability to do sub-transactions. Sub-transactions are identical to transactions, except for they occur within a overarching transaction. And why those are exceptionally useful is sometimes there are times where you want to make changes to the Revit database just to see what would happen when you change it, but not necessarily commit it. And that's a good case for sub-transactions. In this script, I'll be showing how to create a sub-transaction, run it, delete some elements, get the element IDs, and then roll it back so that I can manipulate those element IDs without committing it to the database. Another thing I want to cover briefly is if you're going from Revit elements being input into your Python script, you need to call the unwrap element method to convert your input from Dynamo elements to Revit API elements. To do that, simply like if I had Dynamo elements coming in, my first input, I would take and call unwrap element, and then in the parentheses put in my my first input. It can be an array, it can be a single object. Don't have to worry about which it is. And then I can start modifying that Dynamo element that I got with my Revit API calls. And then with geometry, if I call to Revit type, I can convert Dynamo geometry to Revit. Now, if I'm going from Revit API to Dynamo geometry, I need to call the to prototype. So not something that you might use a lot, but you know, those are out there for if you need to convert back and forth between the two. All right, so I'm going to take and show you kind of how the script works. So the script that I have prepared here, what its goal is to replace line styles that are of the wrong type. So you'll see over here in my Revit window, I have one that's green, which is my line style of to replace with, and then a red one is the to replace. You know, not creative naming, but we're trying to get rid of all the red ones and replace them with the green ones. So here I'm reading in my Python script, reading as a text, and I am supplying the name of the line style to replace, and to replace with will be the line style to replace them with. The Boolean operation here is to inform my script if I want to delete the line style after I have replaced all those line styles, or lines that have that line style. So in my script, let me bring that back up. You'll see that I'm using Visual Studio Code. It is my preferred IDE or integrated development environment for working with Python code. And there are other ones out there. So for example, Notepad++, Sublime Text. It's up to you to find whichever one you feel most comfortable with. And the reason why I prefer to use an IDE versus just typing into the Python script is because you get better structuring, colors, more tools to help you develop using an IDE. So here I'm bringing my CLR, Common Language Runtime. I'm adding my references, and I'm importing these Revit API classes. Now, you don't necessarily know which ones you're going to need ahead of time. You don't want to like be down here typing and then come back here and add it. You can bring in everything all at once under that namespace using the asterisk. The problem with that is it's very memory intensive. So in order for your code to be more efficient, you only want to import the classes that you're going to actually utilize. Now, I say you might not want to, be going back and forth, going and typing typing which one, but you also don't want to bring in everything all at once. So after I get done writing my code, you'll see down here, element category filter has a squiggle under it, and it's coming from the Revit API. It lets me know that I should probably import that class. So if I undo that, and you'll see that it's now identifying that I'm actually importing that class. So here's where I'm getting my document, UI app, and UI doc, as I covered earlier. I'm taking in the name of the line style to replace, the one to replace it with, and the boolean to determine if I'm going to delete the line style I'm replacing. In this case, I'm going to. I'm using Revit API's element category filter to get all lines. So I'm collecting all the elements from my document or my project, seeing which ones pass the filter to see if they're lines, and then I'm getting the elements from them. So this is where we're actually getting purely into Revit API. Up here was my entry point from Dynamo, and then after that, I'm just going straight API, Revit API. And I'm also collecting not only just my lines, but also my filled regions, because filled regions have detail lines around them that need to be replaced. I'm also creating a dictionary so that I can collect all my line styles by their subcategories, and I'm mapping them to a dictionary that stores them by name as the key and the value as their element ID. And what this will allow me to do later is take and specify which element ID associated with that line style to set my lines to replace. Once I get my line style subcategories, I get the line styles that I'm wanting to replace and replace with by name. So I'm using the get underscore item. You'll notice that some cases of Revit API, it'll just say for properties, just call item. Or you'd say, dot item. But with Python, sometimes it requires that you do like a get underscore. You'll learn the nuances as you get more adjusted to how to use the Revit API with Python. And then from that, I'm getting my line style that I'll be using to replace those using the projection instead of the cut. So call my transaction manager, start up my transaction, get it going. So I'm ready to manipulate the database, and I start cycling through my lines. And as I go through those lines, I'm seeing, what is the name of the line style? So if the line style matches the name of the lines to be to replace, I'm then also checking to see if they belong to a group. You'll know if it belongs to a group because the group ID will be greater than 0. If it's -1, it does not have a group. And you can't change things if it belongs to a group. So you have to collect which ones are, what those groups are, and then later ungroup them and run the script again. But if it's not in a group, I just simply set my line style to the line style to replace it with. If it does belong to a group, I'll just simply collect my group names so that in my UI pop-up that comes at the end, I'll know which groups I need to go find and ungroup. Same thing with the field regions. But with field regions, I'm using those sub-transactions. Because you can't get the detail lines going around the sub-region whenever you sketch it out without first deleting the sub-region, what I'm doing is I'm calling that sub-transaction so that I can delete that region and then get the line elements that define the sketch and get their types. Then I collect all the IDs that were deleted during the process, and I roll it back. Now, whenever I roll it back, they're there available for me to work with and manipulate. I take a see which ones are detail lines, and then, again, just like with the other lines, I switch over their styles. If they belong to groups, I just collect the group. And then at the end, I call my transaction done, and then make my Revit API test dialog show the output of that, where the results is the title and output is the body. So seeing this in action, I'll go ahead and give this a run. So run, the first run is always a little bit slower. It says that I have a few of them here in groups 2 and group 1. So I replace that one. Detail regions, if I was to save this, close it, open back up, this would actually have a green border. but to visually update it, I just need to just click into it, edit it, and they're switched over. So if I was to edit these groups, or say ungroup them, run the script again, make a quick change here so that it understands it needs to go again, say run, and replace those, and it says it was deleted. So since it was deleted, my lines turned black as it didn't recognize what it's supposed to visually update with, even though in the data it is the correct one. And if I go to my settings and additional settings and line styles, I now no longer have that to replace line style because I said to delete it. All right, so that's just a very quick overview and example of how you can use the Revit API with Python and Dynamo to do more powerful things that you cannot do just through Dynamo nodes. And with that, I'm going to hand it over to Donnell. I'm going to stop sharing and get it back to him. All right, Donnell.
Hey, thanks for explaining that. He does a lot of work for me. The kind of the flavor when we talk about Pi Revit is kind of the same kind of stuff you need to think about and look at. And we're going to go dive into that. First thing, we're just going to talk about what is Pi Revit. Give you the good, bad, and the ugly, the pros and cons of Pi Revit. From there, I'm going to give you some tips and also show you how you can utilize the API and kind of some add-ons in order for you to be able to utilize it and create your own scripts. And then from there, I'm going to give you some resources where you can go on a lot more about Pi Revit, which you should hear from us today. So what is Pi Revit? Pi Revit is an application development environment using Python. That is a fancy name for an environment that allows you to create your own tools. And that was created by Eisen. I'm probably butchering his name. No matter how many times I try to hear it, I always say it wrong. Eisen, but very smart individual, created this application. This is an add-on to Revit. It's open source, so all the code that goes into creating this, you can look at it and view it yourself. And also being as open source, other communities, other people can kind of add to it as well as you can add to it yourself, which is a great thing about it, why we can use it for Revit. And even if you don't like Python, know what Python, I find that Pi Revit is a very good tool. And you can utilize it without even needing the code because it comes with a lot of built-in tools. And they're worth exploring. You should always check it out. So I always advise anyone who's using Revit on a daily basis to kind of check out Pi Revit because it has some good stuff in there. All right, so good, bad, and ugly. The only bad I can really say about Python, because I really like it, I'm kind of biased, is that it's a community product. So Eisen has created this and has updated it himself. He may have some community contributors, but it's really up to him. So if his life changes at some point in time in his life, you can go in and not use it. It may not be developed anymore, not used. So that's kind of one of the bad because you rely on an individual person to use their free time to create this versus a company who's gaining profit from it, like Revit. The pros of it is it's open source. So, remember last time I talked about how open source was a bad thing for Python, but here's a good thing. And the good thing is that other people can jump on it and create different tools for you. You can also look at their tools and see what they've done. So it's a great learning environment for you. It's deployable, so it's very easily deployable. I've used it in the past. We've placed all the scripts that we're using for the company onto one place on their drive, and everyone's able to access it. It's also quick. It's very, very quick for you to create and test. So in that same put on a server, someone uses a script that said, hey, Donnell, there's something wrong with this. Could you fix it? Can you help me? I was able to update it right then and there, and the person can use it right away. So there's no, talking about Python is interpreted language, so you can get everything right on the fly to interpret. So that's a great thing about Pi Revit. That's also one of the reasons why Eisen used Python versus any other language, because you have that readability, that quick, fast, seeing your results and what goes on with it. The last thing is the embedded data tracking. So today we're in the land of the numbers and when everyone wants to know about data, and this is a very good way to utilize, see how people using Pi Revit is all embedded within. You got to do some backend stuff on your server to do that, but you can gain all the data right up front. All right, so now some tips. And then here are the tips. I'm gonna show you some stuff about the Revit API, and Carlo already told you that you can literally use C#. C# and Python are very close, just need some changes. So that little graphic on the right-hand side kind of shows you what you can do to change it. So this is coming straight from API docs, just as in view to get some information from views. right? So the first line, where you see the blue on the left-hand side, you see my def. They're just defining a function here in C#. Well, the defining function in Python is just use def, so you can get rid of that line, just put def. These red lines here, those red lines are basically typecasting. So with C#, you have to tell it what this container, this message is a container that's storing a string. So what you need to do is you need to tell, the program that I want to put a string in here. In Python, they don't do that. They can figure it out. So whatever you put in there, it'll take it, and it's okay. So you can get rid of all those typecasting. That's all the red lines here. All right. Next thing is the comments. The comments are these yellow blocks. C# uses a \/ to put a comment that it doesn't read in code. Python uses a pound sign. Just replace that slashes with a pound sign. And then the last thing that you need to adjust in here is all those semicolons. C# uses semicolons to denote the end of a line. In Python, when you hit enter, you're in the line and it denotes that. So you can get rid of all those. So with those small changes is getting rid of those typecasting, changing that one thing to def, and then get rid of all those semicolons, as well as removing the backslashes. You're able to get some working Python code using the Revit API, which is really nice. All right, so now I'm gonna go and share my screen. So I'm gonna show you, I haven't explained much. I'm gonna show you how you can use the Python shell, which is an add-on that you can get for Revit, and the API to help you manipulate and see what you can do with the API. Share my screen right now. All right. Now I have this project up. Make sure everyone can see my screen. There we go. So you have this project up, and let's say I have a wall in it. I want to see some stuff about a wall. So I'm just going to create a wall. This is an 8-inch generic wall. I'm going to place in my drawing. And I'm going to select it, and I'm going to go over to my add-ons where that you see that interactive Python shell, that Revit Python shell. I'm going to click on that. It takes a little setup to get it this way, but you can use that. So now I want to see what can I use, what can I do with it with Revit. So I need to know what type it is. I'm going to type in, put type. I need to know what type it is. And then inside of that, put E1. E1 is the object. So when I selected this object, it's stored in an E1 form already. So it's already a bucket form. I hit enter, and then it tells me a wall. So I take that information, and I will go into Revit, the Revit API docs. Go in there. And then I'm going to go whatever Revit you're using. We're in 2022 here. I'm going to type in wall. Right, what comes up is that wall class, right? So what I want to learn from this wall is what can I do with it? So if I click on wall class and click on members, this is all the things I can do to it, which is a method, and all the things I can read from it, which are properties, right? So within properties, I'm going to notice that there's a property called width. So what I'm going to do is I'm just going to copy that, all right? And it's a property. I know it's a property because it has that little icon to the left of it, as well as it's under properties. I'm gonna go back to my Revit Python shell, and I'm gonna get my item, my wall, which is E1. I'll put a dot that says I want to do something to it. And being that's a property, you don't need any parentheses, just put that in there. It also comes up in its quick access tool as well. This IntelliSense, I'm sorry. And then I hit enter. Now I get the 6.66 in feet, or 8 inches in feet of that width. I got that. So now we need to get the length. And the length, if we go back to Revit Python shell, back to the API, there's no length in this list or in the list here. So what you can do is work around it by going to the Lookup Parameters. So I'm going to take that and click on Lookup Parameters, and then go in here and it says Lookup Parameters, right? So when you perform this, this gives you what's on the left of this command. So Lookup Parameters is the command, all right? String name is what you need to do to get it. And then when it's done, on the left side, it's going to tell you what it gives you, all right? So now if I go back to Revit Python shell, my item is E1, that's my wall. I'm going to paste that lookup parameter, and then I want the length, so I'm going to put that in quotes, length, and close it. So now remember that if I close this, I stop here, it's going to give me a parameter. I want it to tell me exactly the length of it. So I'm going to go right back to Revit Python shell, API docs, sorry. And then I'm going to click on this parameter. That's what I'm going to get. What can I get from parameter? I go to the members, right? and I just look down. And here what we'll find is that you'll find as value as string. I'm going to select that and then copy that here, Control C, and go back and put a dot because I'm still trying to perform it on this parameter and type string. Now I'm going to hit enter, and that gives me 95, which is exactly here. Right? And that's how I'm able to use the Revit API docs and Revit Python to start testing stuff to see what I can do. Now, anything that you write in Revit in Pi Revit or for Pi Revit, you can literally paste in here to see how it works and what it does. So you can always use this for testing. One other bonus add-on I'm going to give to you is that you can use Revit Look Up. Revit Look Up tool is a very nice tool to give you the same kind of interaction that we did here. So if I select that wall again, go to my add-ons, and then go Revit Look Up and then snoop the selection, which is just that wall. Now here, everything in that method is going to be printed out here in some sort of way. So if you scroll down to the bottom where you start seeing the properties, you'll see that the wall width is there, which is the 8 inches. All right. And then if we want to look at, we have to do the Revit Lookup parameter in order to get the length. So we got to just look for the parameter map. I'm going to click on that. And now I get a list of all these parameters that's on there. One of these is length. I click there. Now I'm getting some information on the length. And then I'm sitting here to 95. Remember, all this stuff here is what we saw when we looked at parameter in our wall class. We looked at parameter class. We saw all those different things. So you can use that to kind of research and look at what the items are too as well to kind of help you build and see what you can do. Remember, we're controlled by the API. If it's not in the API, we can't do it. Okay, so now we just talked about the API. Now let's talk about, kind of exploring and doing some items and Pi Revit, see how that looks. I'm gonna go over to this DG testing. This is kind of where I test and play around with some items. If you hold down the Alt key and select anything that brings you to this location. So I'm gonna select this wall because this is gray and go back to that DG's testing, Donnell Grantham testing, and then hold the Alt key down and left click on that zoom. All right, it brings up a folder, and this folder is kind of where the script is living in the structure. So we can get a hint at the structure for Pi Revit. On the left here, you give the tab. So this is a folder that just says DG testing tab that collides with that. That's equal to that. Then we have another folder that says view utility panels right here. Then we have zoom to selection, push button. So this is a push button. It's called zoom to selected. Within that folder, we have two items we really need. The third item is kind of me just testing and playing around because this is my test environment. So the first one is the icon. So the icon is exactly what's there. So I just placed a PNG with the name icon on it. It'll give me that icon. That's what's going to be used within Pi Revit. And then if I make a script called zoom selected, and at the end of it, put an underscore script.py, that's going to be the script that gets executed when I click that button. I'm going to show you that. So, Carlo told you about the IDEs. I personally use Visual Studio Code. You can use PyCharm. You can use Notepad+. We don't go heavy on it because when you start learning and you go to your first document, first book, or first lesson for Python, they're going to talk about IDE and use it. And from there, you'll use it. You'll find what you like best, and you just use it from there. All right, so this is an example of the code for the Pi Revit. So here at the top, Dynamo has a boilerplate code that gets you to access everything. You don't need to do CLR because you're accessing the API directly, unlike with Dynamo, you're accessing them inside Dynamo. So you need the CLR, you need some other stuff to access it. But so for Pi Revit, this is kind of sets up the document. So this document right here just tells you what it does. All right, the title is what you see here. So zoom selected. That /n is a way to make a return. The author, just for some purposes in terms of logging, this text here, this context here is for selection. That means I have to have something selected in order for you to use it. So if I don't have it selected, it's gray. Selected, it is not. Right. And let's go back to that. All right, so I have that kind of like the setup to give you some information. From here, I cast all the information I need. See, I don't need any CLs or anything like that. I just go into the Revit database and get the items that I want. Right? And then from here, the docking UI docked. Carlo did a great job of explaining what that is. That's what we're using here. same exact thing. And then from here, we're just zooming in, so we don't need any tracking actions. There's no wrappers or anything like that within Pi Revit because we're not inside the program. We're kind of directly accessing the Revit API. So in this particular one, I want to point out is that in this particular one, we're using this command called UI.UI document show element. That's the command. And what we're doing here, we put it in the Zoom group, and the Zoom group is looking for a list element ID. And that's certain commands need a particular list. I'm gonna show you what that looks like. So we're gonna navigate that in API docs. So we go UI document. So let's go to that website, go into our document. I'm gonna go all the way up to the top of this. So I start looking at namespaces, a little faster. Time limit here. Up here. Okay. So I'll remove that namespace so I can get all the namespaces. I'm looking for the namespace UI. So UI namespace. Then we're looking for UI document. So I'll scroll down to the bottom, UI document, and I click on the members. And then in the members, we should have something that says show elements. So in this elements right here, we're using this one. And these are all, this is what you mean by overloads, meaning this is the same command, but it has different inputs to show you. That's what Carlo was talking about before. We click here and it says iCollection of element ID. So that's what I'm doing here, is that I'm creating this list, and this list is from this system generic, which is the .NET, this list. And then we're just saying this list, we casting that list as a list of element IDs, that's what it means. And then putting all those element IDs that I got from the selection that you have to zoom into it. So now if I click on it, click on this item, zoom far away, and go back to that item and click it, it'll zoom in for me. I kind of created that because I was copying and pasting some elements, and some elements were really far away from the screen. This kind of helped me find my items. That's why I did that. All right, so now I just showed you that. We're gonna show a little bit more complex one. That was pretty easy. I'm gonna show you, so I'm holding down the Alt key again, going to this item called column top reinforcing. This is a script that just adds column reinforcing. The same thing here. Remember, the way it structures in Pi Revit is that if it's icon.png, that's what's used for the icon here. And underscore script.py is used for the script that's executed. Everything else is just kind of ignored. So I'm gonna open that up in Visual Studio Code, right? And it's a little bit more information, but you notice that here, transaction, this is just like in C#. So I always say that Pi Revit feels like you're really coding, and like, I feel like it's more like what I'm used to when I was learning it, and the examples that I was given when I was learning it, because you didn't have to do a lot of CLs and unwrapping and wrapping stuff, and the way they do transactions is a little different than what you see in C#. So this is what helps it there. So I'm going to show you down, scroll you down, doing some stuff with it. I want to show you that unlike Pi Revit, unlike Dynamo, you just go and get make the transaction group. Then you start the group, and then from here, for each individual column reinforcing that I'm placing, I would just put a transaction, create a new transaction, start it, commit it, and then I commit the whole entire group, just like how I would document it in C#. All right, so that's a good tutorial on how we can use the API to use the API docs, as well as Revit Python shell to kind of create your scripts, as well as I showed you some structure of the Revit API. I'm gonna stop sharing and go back to our presentation, right? And as you can see, up. As you can see, if we go back here to our PowerPoint, I'm gonna give you some resources. These resources is from Pi Revit. I think they have very good resources to show you a lot of things. So you can go, I find that if you go to the Pi Revit YouTube channel and go to this playlist at the very bottom that you see on the screen with the star on it, that Pi Revit for Python for Revit course. That courseware is a really good course to get you used to Pi Revit and learning it. That's kind of where I started my Pi Revit journey.